All right, the last time we left off, we were looking at the law of sines. We were solving oblique triangles. So just keep in mind an oblique triangle is a triangle that doesn't have a right angle in it. Right? Two types, there's an acute and obtuse. We talked about the different cases and the data required to solve each case. We looked at the side, angle, side, angle, and the side, angle. All right, we would start those with the law of sines. There is an ambiguous case for this S side angle. We don't deal with that ambiguous case. So if it's a side angle, it's a straightforward type problem. Today we're going to deal with the law of cosines. So these are for cases 3 and 4 where you have a side angle, you're given a side angle, side set of measurements. And also if you're given 3 side lengths. All right. Now, as far as the law of cosines form is concerned, you generally only see these 3 formulas, right? A squared is equal to b squared plus c squared minus 2bc times the cosine of a. And it's like a pattern to these things, as we're going to see. There's a formula for b squared and there's a formula for c squared. However, when you're solving triangles, you never really solve for a squared, b squared, c squared. You want to know a, b, and c. So in order to find a, b, and c, you simply take the square root of both sides. So like for this first equation, a squared is equal to b squared plus c squared minus 2bc times cosine a. If you square both sides, notice that the square root and the square cancel, and then the square root is stuck on the I thought I changed that. I believe it's right on the notes. Let me just double check that. Okay. Okay, yeah, it's actually right on the. So if you square both sides, notice you get the square root and the square cancel, and then you have b. The square root is sort of stuck on the opposite side. So that's what happens for A, B, and C. These formulas are also solved to find angle measures. You can find angle A using this same formula. You just have to solve it for A. So if I already done the liberty to do that, I'll actually do one for you. This is the formula to find B, and this is the formula to find C. All right, so in order to get this formula, let's say for angle A, this is actually what happens. This formula, this first formula, a squared is equal to b squared plus c squared minus 2bc times the cosine of a. And we're going to solve for a. So the first thing I'm going to do is just push everything that's not attached to a to the other side. So I'm going to take b squared, c squared, and a negative 2bc, and I'm just going to transpose and move those to the other side. So it looks something like this. So a squared minus b squared minus c squared. Well, that's right. That's right. Is equal to negative 2bc. That's right. Cosine a. Right. So I'm simply taking B squared, subtracting that from both sides, taking C squared, subtracting that from both sides. The next thing I'm going to do is divide both sides by negative 2BC. So it looks like something like this. I'm going to flip it around. So cosine A is equal to A squared minus B squared. And that should be plus C, minus C squared over cosine A. Right. I'm sorry, over negative 2BC. I'm sorry. So I divided both sides by negative 2BC. And then the denominator is made positive, and then it's just a play on these signs. So, for example, a positive times a negative makes that entire number negative. Okay, so this is what happens in the formula. So notice that my denominator is now positive instead of negative. So it's like I'm just changing the signs of the numbers in the top. So B squared becomes positive, and C squared becomes positive. Right? And then in order to solve for A, not the cosine of A, we take the arc cosine of both sides. So A is equal to the arc cosine of B squared plus C squared minus A squared over 2BC. Okay. So that's where the formula for A comes in. And let me copy this over real quick. I thought I had it. Insert picture. Okay, and I don't know why I put it down here, but all right, so that's where the formula for A comes in. All right. There's a formula for B that's done the same way and for angle C. All right, so you're given like the root formulas, and this is what you always see, but they're not the actual formulas that you use. All right. So the formulas that we have here, the derived formulas, these are the actual formulas that we're going to use. All right, now there is some suggested procedures on how to answer these questions. We talked about case one and case two in the last class. Case one for side angle, and angle side angle. It says the first step you should do is find the third angle, right? Because if you know two angles, and the fact that they're 180 degrees and in triangle, you can find the third angle, and that's what you should do first. The second says find the remaining sides using the law of sines. All right, we did that. For side angle, it says it's the ambiguous case, but that is beyond the scope of this course. We're always going to have one triangle solution. It says find the angle using the law of sines, find the remaining angle using the sum formula, and then find the last side using the law of sines. For the law of cosines, these are the third and fourth cases. If you have a side angle side And this law of cosines is set up for side angle side and side measurements. It says that the first thing you must do is find the third side using the law of cosine. If you have a side angle side set of measurements, I'm going to move this over. All right here. So let's say we have a side angle side set of measurements. Okay, I'll just draw it this way. So you'll be given the length of one of the legs, one of the sides. I'm going to call that leg 1. You're going to be given the angle measure, right, the included angle, and you're going to be given the measure for another leg. So you're going to have 2 legs and the angle in between the 2 legs. This is the side angle side setup. Whenever you have the side angle side setup, you always use the law of cosines to find that third leg. So like in the formulas where we see like a squared, b squared, c squared, all of this, if you can think about it in these simple terms as 2 legs and an angle, this is what the formula would look like. So let's say to find that third side, that would equal to the square root of one of the legs squared plus the other leg squared. So this is like the pattern. Minus 2 times one of the legs times the other leg times the cosine of the given angle. So once again, when you're given a side angle side set of measurements, you find the third side using law of cosines, and this is basically a law of cosines. It's the square root of one of the legs squared plus the other leg squared minus 2 times both of the legs times the cosine of that given angle. Then it says, after you find the third side using law of cosines, then you should find the smaller of the 2 remaining angles using the law of sines. Now, unless they're specifically telling you to find an angle, if you're asked to solve the entire triangle, I would use these suggested procedures, because if you find an angle that's out of place, then you might notice your answers will be slightly off, and this would be the reason why. So a side angle side set of measurements, find the third side using the law of cosines. Then you find the smaller of the 2 remaining angles, and then you can find the remaining angle using that sum. Lastly, if you're given a side set of measurements, you should find the largest angle first. Unless they tell you to find one angle at random. If you're solving a whole triangle, I would use this suggested procedure. I would find the largest angle first, And then after you find the largest angle, so just remember that the largest angle is opposite the largest side. Once you find the largest angle, then it doesn't matter what you do next. You can find either of the remaining angles, but you got to find the largest one first. Right? And we're going to see a problem that kind of goes against that. All right, so let's take a look at the first example. All right, so they're telling us to find the length of side x round to the nearest tenth. So here again, notice that they do not tell you which set of formulas to use. The way you can tell which set of formulas to use is look at what you're given, fit it to one of those cases, and then use the procedure for that case. So as I look at this, they give us the measure of a side length. They give us the angle included between the other side lengths. So this is a side angle side case. Right. So the case is determined based on the dimensions that they give you. So if I take a look at my suggested procedures, it said for side angle side, we have to find the third side using all cosines. So here, that's actually what they want us to do, is to find that third side. All right, so I'm gonna actually use, since they don't label this triangle out like an A, B, and C format, you can put A, B, and C to it. Or just notice, based on what we did earlier, if you have two legs and a measure and an included angle measure, you can simply write this out as x is equal to, I'm going to take one of my legs, which is 9.1, square that, plus the other leg, which is 7, we're going to square that, minus 2 times leg 1 and leg 2, times the cosine of the given angle, which is 72 degrees. So instead of using a formula, I mean, you could go around and label this as A, B, and C. Right? I just used the simple fact that it was two legs and the given angle included, and I just used this pattern. Now we got to put this in the calculator. Okay, I'm going to put it all in the calculator as one step, and you want to be careful to keep up with your parentheses. Whenever you're putting parentheses into the calculator, just remember you should always have an even number of parentheses. For every beginning parenthesis, you should have a closing parenthesis. All right, so I'm going to put in the square root, and notice that it gives me a begin parenthesis. I'm going to put in 9.1 squared plus 7 squared minus, and for the multiplication, I'm not going to use parentheses. I'm just going to use a multiplication symbol just to reduce the amount of parentheses I'm using. So this is 2 times 9.1 times 7 times the cosine of 72 degrees. So let me just make sure I am in degree mode, which I am. I want to close off my argument for cosine, and I want to close off my radical. So I have an even set of parentheses, 1, 2, 3, 4, and I get 9.6. Okay, as the length of that missing side. All right, any questions about that one? All right, for the next example, and this is the one that kind of goes against the grain of those suggested procedures, and only because it wants you to find just one specific angle. So this says find the measure of angle A, round to the nearest tenth of a degree. All right, so it doesn't tell us which set of formulas to use. So notice that we're given the length of all three sides. So this is a side, the last case. If you look at the suggested procedures, notice that it suggests that you find the largest angle first. Now, this is what I'm thinking. Since they didn't ask us to solve the entire triangle, they only want us to find angle A. So I'm only going to find angle A. Right. But if this were a problem where they gave me three side lengths, if it would look like this, then I would use that suggested procedure. Does everybody kind of see what I'm saying? Because you may get slightly different answers. Like if this thing did not want me to find angle A first, I wouldn't find angle A first. I would actually find this angle first because it's opposite the largest side. Okay? But since this wants us to just find one angle at random, all right, I'm not going to use a suggested procedure. So I worked this in an office and it worked out to be the right answer, just because they're telling you to find this one angle. All right, so it says find the measure of angle A. So this is angle A. I'm just going to label the sides because I'm going to use a formula. So this would be side A, right, which would be opposite angle A. Doesn't really matter what I call B or C. I'm going to call this angle B, and I'm going to call that angle C. So now B, side B is going to be 17.2. And then the side opposite angle C is side C. So I want to find angle A. So if we look back at our formulas, this is the formula to find angle A. It's the arc cosine of B squared plus C squared minus A squared divided by 2BC. So I'm just going to write that above the problem. So A is equal to arc cosine all right. So we're going to substitute A for 16.1, B for 17.2, and C for 9.3. All right, so this is the arc cosine of okay, so I believe this is what we should have. Right, the arc cosine of 17.2 squared plus 9.3 squared minus 16.1 squared divided by 2 times 17.2 times 9.3. So we're going to carefully enter this into the calculator. All right, so I'm going to put in the arc cosine. Notice that gives you a begin parenthesis. I'm going to insert another begin parenthesis, and this is going to be the parenthesis for the start of my numerator. Put that in right. All right, so that's that parenthesis. So now I'm going to put in 17.2 squared plus 9.3 squared minus 16.1 squared, and I'm going to close off the numerator. All right, so I'm going to close off the numerator. Divided by, I'm going to open up a set of parentheses for my denominator. So I'm going to put in 2, and I'm not using these parentheses. I'm going to use the multiplication. Times 17.2 times 9.3. I'm going to close off the denominator. And then you have to close off your arc cosine function. So I should have 1, 2, 3, 4, 5, 6. I got 6 sets of parentheses. And if you round, I believe that's 67.4. So A is equal to 67.4. So is everybody okay with that one? Now I entered it in all in one step, but you could just very well simplify the top, simplify the bottom. You can do all of this in more than one step. All right, now the very last problem. For these type problems, when they don't give you a triangle and they don't tell you really which order to go in, then you should use that suggested procedure. So first off, they just give us 2 sides and an angle measure. So I'm going to sketch this out. We're going to put a case to it, and then we're going to look at the suggested procedures for that case. So I'm just going to draw triangle, all right, ABC. All right, remember that capital letters are angle measures, lowercase letters are side lengths. So side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. And then just jot in the given information. So A is 7, B is 12, and angle C is 93.7 degrees. So just by looking at this, this is a side angle side case. Right, 2 side lengths and an included angle measures are given. All right, so if we're looking back at the side angle side case, it says find the third side using the law of cosines. Then we must find the smaller of the two remaining angles. And then we use the sum formula to find that third angle. All right, so since we have A, B, and C, we can actually use a formula, right? The only thing I can find here is side C. So we're going to find C. We're going to find C. So the formula is C is equal to A squared plus B squared minus 2AB times the cosine of C. So that's basically that pattern. One of the legs squared plus the other leg squared minus 2 times the legs times the cosine of that given angle. So we're going to substitute A for 7, B for 12, and C for 93.7 degrees. Right, so that gives us 7 squared plus 12 squared minus 2 times 7 times 12 times the cosine of 93.7. So I'm just clear my calculator. So that's the square root. 7 squared plus 12 squared minus 2 times 12 times 7 times the cosine of 93.7. Close off the argument for cosine. Close off your radical. And we get 14.2. Or 14.3, I'm sorry. So now here's what I'm going to do to avoid rounding error. I'm going to take this value for side length C and I'm going to store it for C. So once I had that answer of 14.277, I just hit STO, which is short for store. And I'm going to find C and its alpha and program. Right, and you can recall them, those numbers, the letters through the numbers. So I'm going to keep the true value because you may run into some rounding error stuff. So to avoid it, I only want to round the final answer. All right, so we had to find C first. The next thing we should do is find the smaller of the two remaining angles using the law of sines. And this is sometimes where you can go wrong. Right. So if we take a look at our diagram, which side would be, well, let me jot inside C, that was 14.3. So A was 7, B was 12, C was 14.3. Angle A was 93.7. So what angle should we find next? Should it be B or C? Well, in order to determine, look at the smallest side. Because the smallest angle is opposite the smallest side, the largest angle is opposite the largest side. So the smallest side is side A, so we're going to find angle A next. All right, so we do have a formula that we just used, right, to find angle A. So So A is equal to the arc cosine of B squared plus C squared minus A squared over 2BC. We're going to substitute A for 7, B for 12, and C is 93.7. I'm sorry, we just need A, B, and C. And we just found side C is 14.27730.464. I'm going to use the true value. So this is the arc cosine. Okay, so I think it looks something like that. So I'm going to put this in as the arc cosine. I'm going to put in a begin parenthesis for the numerator. 12 squared plus C squared minus 7 squared. I'm going to close off the numerator. Divided by, I'm going to open up a begin set of parentheses for the denominator. It's 2 times B, which is 7, times C. Now it understands that all that's being multiplied. Close off the denominator, close off the arc cosine function. And let me do that again. Let me do that again. I did something not right. Arc cosine, begin parentheses, 12 squared plus C squared minus 7 squared, close off the numerator, divided by, open up a set of parentheses for the denominator, 2 times 7 times C, close off. Did anybody else get an answer? I don't know what I am not doing right. Arc cosine minus A which is 7 I don't know why this wasn't checking out the first time. 12 squared plus C squared minus 7 squared divided by 2 times 12 times C. So that should be 29.3. So B, well, no. A is 29.3. So I don't know what was going on when I put it in before, right? But I do have an even set of parentheses. 1, 2, 3, 4, 5, 6. All right. So now lastly, we want to find C. And we're going to use the sum formula. So C is equal to 180 degrees minus 93.7 plus. So to avoid rounding error, I'm going to store this for C. So it's going to overwrite that value for C that we just had in there. I'm going to store that for C. So now if I put all of this in, 180 minus a begin set of parentheses, 93.7 plus the value for C, and we get 57. So B is 57 and A is 29.3. All right. So that would solve the oblique triangle. All right. Any questions about the law of cosine?